I am convinced that almost everyone who's writing software, they know at least one thing they can do to be more efficient. And they might not be able to say it's like a 10 times more carbon efficient or even 1 time more carbon efficient, but they know it will be better.
Hello everyone, welcome to Green.io, the podcast for responsible technologists building a greener digital world, one bite at a time. Every 2 Tuesdays, our guests from across the globe share insights, tools, and alternative approaches, enabling people within the tech sector and beyond to boost digital sustainability. Because accessible and transparent information is in the DNA of Green.io, all the references mentioned in this episode, as well as the transcript, will be in the show notes, both on your podcast platform and on our website, greenio.tech. O'Reilly books remain a world-class reference when it comes to sharing IT knowledge. It kind of set the tones on what matters in the software industry. And to be honest, if you do a quick research on a topic like security, you will easily find 10 to 12 books talking about these topics in the last, I would say, 5 years. I did the exercise with machine learning and AI and data, and it's just overwhelming. And then when you do the exercise with sustainability, I have to say that until this year, the only book mentioning clearly sustainability in its title was the one from Tim Frick, which was published way back in 2016. So it is a fair statement to say that the new O'Reilly book, Building Green Software, written by Anne Curie, Sara Bergman, and Sarah Su, has been very much weighted in the green software industry and the green software community. So this is why I'm delighted to have today on the show Sara Bergman with us to talk about the latest trends and what are all the angles to be covered when you truly want to design and to run and to maybe sometimes decommission software in the greenest possible way. Sara, as I said, is one of the co-authors of this book. She is a senior software engineer. She works at Microsoft. She's based in Norway. And I think I have to give her double kudo in this episode because this year she gave birth twice. First to a wonderful book, much acclaimed and much awaited, as I said, but also to a beautiful little boy. So nice to meet you, Sara. Congratulations for bringing yet another beautiful human being on planet Earth. And thanks for joining the show today.
Thank you. 3 times. Yes, it's been quite the exciting last 12 months indeed. Really glad to be on the podcast. Thanks for having me.
You're more than welcome. And Sara, if you listen to us, the other Sara, you know you don't have to be jealous because you will also join the podcast at some point in September. And you're the one in Green.io London, the conference, the on-site conference, that will have a book signing session. So we will have the 3 musketeers on the show at some point or the other. But Sara, before we jump into the nitty-gritty of building green softwares, where you will bring your own expertise. I mean, I must say, I admire you so much. Every time I try to write an article, it's great for, I would say, the first 2/3, and then I just can't make it. I just cannot close the project, etc. It's just a little article, and you wrote a book. You have to tell me what is your secret recipe to manage to write a book on top of being a very active member of the climate action tech community, a very active member in the Green Software Foundation, a very active member, I guess. I mean, you're still on their payroll at Microsoft. So how did you manage?
Yeah, also while being pregnant. Well,
I mentioned it, but I didn't want to bring it yet another time in the discussion.
Yeah, sometimes I question my life choices. Sometimes I'm very happy with my life choices. No, but I think there were several things. So first of all, I got the question to co-write this book. It was in the early stages of my pregnancy, and I was like, is this really a good time? There was definitely a lot of mom guilt from my side. You know, should I be doing this sort of selfish project when I should really just be focusing on my kid. But then, how many times in your life will you get the question to write a book, especially the book I always wanted to write for O'Reilly? Like, I felt this was maybe a once in a lifetime opportunity, and I didn't want to regret it. And after all, my son is going to live on after me. He's going to have a whole life on this planet. So I want to do everything I can do to ensure he has a bright future. So yes, I said yes to write this book, but I wasn't alone, right? I had Anne and I had Sarah. And when I asked other people, like, who have written books, like, oh, what are your best tips? A lot of them said, don't have any co-authors. But I want to say, have co-authors that you know and trust. Anne and Sarah has been, there would have been no book without them. It's been a great collaboration. We work really well together. I'm so pleased to be able to say that. And that's been such a driving function. When you need a little bit of motivation, they had my back and I had their backs, and we could proofread each other's stuff. So that's been a really big part in sort of getting this book out. Also, having deadlines when it's like enforced by someone else can be I am at least motivated by that. You should have this done by this date, and sort of set it up in like a reasonable pace. It hasn't been, in fact, we were a little bit faster than what O'Reilly suggested because we were motivated to get the book out the door. So that was helpful. And thirdly, it's a really fun thing to write about. I think I enjoy writing. I always had, and I miss it in my normal work, so to speak, because then I write code, but I don't write so much text, except emails. I write a lot of emails.
Oh, you don't use the generative AI to do your emails? I'm surprised.
They will take away the creative process of writing emails. No, it's a great feature. It's I enjoy writing. So I guess that was a long answer to a short question.
Yeah, but that's a very interesting answer. Like, I guess enjoying it. You need to find pleasure in entering such a big adventure. And let's talk about green software now. I guess you brought some specialties, some special knowledge compared to your colleague. I remember, for instance, that Anne was very proactive and was very even a bit provocative regarding how you should code, looking for efficiency, trusting a language builder rather than trying to tweak them, etc. She had also a pretty strong stance on AI, who would be a no-brainer when it's about coding and coding efficiently. But I guess you brought other area of expertise, and correct me if I'm wrong, one of them is artificial intelligence and data management.
Yeah, I did write a lot of that content for the book. And I want to say I'm not a data scientist. I am a software engineer. But AI and sustainability has really been a focus of mine, especially my talking career. I had my first talk on that subject in 2020. So that was like before the hype, sort of. And the reason I've been interested in it because there's been so much good research in that field. There's been so many fantastic researchers who have done a lot of studies, published a lot of data on it. So it's been a topic that was really easy to understand because other people had made all this wonderful information available. And I don't know if it makes me weird or not, but I do enjoy reading research articles. I think they're fascinating. I think it's so cool that we as a global community have this practice where we pay people to do cutting edge research and then they publish these results for free for everyone to reap the benefit of. I think that's amazing. So yes, AI was definitely something we wanted to bring into the book. It wasn't actually originally in the plan when we first decided to write it, but then of course with the LLM wave that happened in 2023, it was a no-brainer to include it.
That was actually one of my questions because there is this debate, like, is data management, data science part of software engineering, or is it like a subtopic, or is it a completely different field now? And I don't think it really matters to enter the debate, but I was happily surprised to see a chapter. So what are the top 2, top 3 main takeaways for you if I want to be a sustainable software engineer and I have to deal with large amount of data or AI? What are the main takeaways?
So the main takeaways, I would say the first is to reuse what's already out there. Other people spend a lot of energy and time and carbon to, for example, collect large data sets or, for example, already train models. Can you use those data sets? Can you use those models either directly or use transfer learning to apply them to a new problem domain that's sort of similar? Then you save carbon compared to starting from scratch because you can utilize something that's already in existence. So if you think about the waste pyramid of reduce, reuse, recycle, burn, then the same applies here, right? It's always best to reduce, but if you can reuse, that's great, etc., etc. So that's the first takeaway. Secondly, is to shrink the model size, both the training phase, but also once you deployed it. And shrinking model size is ongoing and has been ongoing for quite some time research space. So there are already all these great techniques. You can prune, you can compress, you can use distillation, quantization, and that saves you time, which is more efficient because if you have a smaller model, you can, for example, train it faster. Train it faster means you can utilize this hardware, this energy you use to power the hardware on for other things. Same with the model once it is in production. A smaller model will take smaller space. You can even use smaller hardware device. For example, you might even be able to deploy it to the edge or to an Internet of Things device. So yeah, that's the number 2, shrink the model size.
And regarding this smaller is beautiful approach, you mentioned edge computing. Do you believe that that's a viable option when it comes to AI?
It really depends on what you're using AI for and the type of model that you have. I think for some scenarios, it's absolutely viable. And not all AI needs to be these huge models. I believe we can use it for smaller things perhaps as well. And then I think Edge can be really good. It's also a great way if you're using use your data to train your model, then you can even use something called federated learning, where you train your model closer to the end users. You sort of collaborate on a model. And in that case, Edge can be good because you don't have to transfer all the data back and forth to your data center, but you can rather share the model and not the sort of data itself, if that makes sense.
I didn't know about federated learning. Could you share an example? Did you have some ideas and illustrations in your mind?
So there is a paper actually called "Can Federated Learning Save the Planet?" and that's really good. In that paper, they had some examples of what they used it for, and then they compared it to traditional like centralized data center training, and saw that this can be a bit slower to converge. Obviously, because you have all the end users collaborating on a model, but it can also be a greener approach, and mostly because you're more efficient in how you use your hardware and you use the network less as well.
And do they provide an order of magnitude? Is it like 5 times, 50 times, 1 million times less carbon intensive?
Yeah, they're a little bit careful because it sort of depends on external factors like the grid intensity, where do you place the data center, how long do you send the data. So it's a lot of ifs and buts, the way it can be in green software. So it's not super straightforward to give a magnitude always.
And you mentioned reusing data and like the 3R of of waste management.
Yes.
I really love it. So of course there is a reducing part, and I think we could spend an entire episode on: do we really need to uh, gather that amount of data, most of it which will not be used? With the reusing, I mean, if I'm a, a software engineer, not that well connected to the AI community, etc., etc. Someone asked me, okay, implement some sort of generative AI, etc., and the obvious answer would be, okay, I'll go for ChatGPT or GPT-3, depending what you want to achieve. And I don't want to do that. Where could I find these models or these data sets that I can reuse now?
Two great places to look at least, is Kaggle and Hugging Faces. They have lots of both data and models open source and available, and they're community led, which is pretty cool.
Okay, so Kaggle and Hugging Face are the two places you would advise people to look for. Jumping on another part of the book, there is something that was really music to my ears, is that you've got an entire chapter dedicated on hardware. And once again, I believe that you're kind of the expert on this topic. And this is not that usual to have a software engineering book going all the way down to hardware, the hardware level. So once again, what are the main takeaways of this chapter, and how could you share useful tips or actionable things to do for a software engineer?
Yeah. So I think there could definitely be a whole book, or like many books on hardware and sustainability. Another area of research and like really focused attention for a long time by the community. It's not anything new. Um, I come from, so my background in engineering was actually half hardware, half software. So I had, course mates who went like me, became software engineers. I have others who design hardware. So that's my background on hardware. So here's the thing: no matter what type of software you write, it runs in some kind of hardware. You have to like face that fact and accept that hardware is a part of your life, even if you just see hardware as like a means to an end. Or if like, there's some people who love hardware, right? They collect old machines, they learn how to program on punch card. Like, those people are still very much alive and kicking and active in our community. So that we have the full range. But either way, like wherever someone falls on that range, hardware is like a fact of life as a software engineer. And hardware comes with this great carbon debt, right? It's incredibly carbon intensive to produce the kind of hardware that we use to run software. What we wanted in the book is to make sure that this is known, right? I don't think anyone is unaware of this fact, but to really make it, to highlight it, to make it clear that this is a fact, and there are things that you in your software can do to affect it. And that's the thing. We don't cover anything on like how do we make hardware greener, because again, that's topic for a completely different book with other experts to write that book, and there's plenty to be said there. However, we as software people have a responsibility for how we utilize said hardware. And there are two main things I want to say that you should be doing. And the first is to increase the lifetime of your hardware. Simply use what you have for longer, even if that's a server in your server hall, or if that is to promote end user devices longevity. So basically making them last longer. And the second thing is utilizing what you have effectively. So increasing the utilization. Again, more relevant, I want to say, on like the server side, where you have more control. If you are programming for end user devices, you can't really control how much like a end user is running simultaneously on their phone, for example. But you can if you own the hardware, and you can if you're deployed to the cloud, by making sure you are using the right tools to enable the cloud provider to be more efficient. And I believe Anne talked about some of those things when she was on here.
And on this specific topic, did you talk about some sort of graceful degradation concept? The fact that I think Ismael Velasco is the one who coined it. Sorry if someone else did it before, but the idea that it's okay that maybe some features won't be available on older devices, and yet they should be able to smoothly run through your services, etc. Hence the graceful degradation, and I love really the graceful degradation idea. Is it something that you believe is applicable? Is it something that you talked about in the book?
But to talk briefly about it, yes. And also how some of that functionality that you may be able to live without should never be security, right? You don't want to leave users on an unsafe device. You still have a responsibility as a software engineer. So that's something we talk about as well. But it's an action-packed chapter, and it's not super long. So it's there's definitely more to be said in the future on that topic.
And I have one last question that literally popped up in my mind when I was listening to you and connecting the dots with the interview I had with Professor P.S. Lee, who's one of the, I think, really worldwide top experts on data center sustainability, especially tropical data centers. He's based in Singapore. And he was telling us something that I guess pretty much all of us we knew, but we don't pay attention to, is that the temperature on which you run your processor matters a lot when it comes to the longevity of your equipment. And my point is, and I'm pretty sure you didn't have this crazy idea in the book, but do you believe that at some point we should introduce in our software some sort of feedback loop, saying like, for instance, if I launch a very massive batch, data treatment, whatever, you name it, real-time processing, I guess, that we should introduce some kind of feedback loop regarding the temperature of our hardware and saying, hey, by the way, if the temperature reaches a certain threshold, even if it doesn't threaten the operation itself, we know that actually we're damaging the hardware. So that could be interesting to pause or to reduce the amount of computing that we are requiring from our machine, whether it's virtual or not, because hence we will literally make its life easier and making sure that the hardware will last longer. Some sort of a temperature-aware computing.
I think that would be super cool. And I think this is where we come into like a distinction of who should write which type of software. I don't think that maybe every software engineer should write that piece of code. It will likely look exactly the same for everyone, but there should be some kind of controlling software that allows you to take these options. So you can just say, when I deploy this, I want to have the temperature aware computing option. So you don't have to make the decision, if that makes sense. It's the same when I use like my washing machine. I don't know how a washing machine is built. I guess it uses a lot of electricity and water. I know there is an eco program though. I use that eco program because I trust that the people who build the washing machine are smarter than me, and they know how to save the most electricity and water. So I just click the button and the washing machine does it for me. Same with this type of software. All software people can like understand how it works. Like, yes, keep temperatures down, make hardware last longer, great. But they just want to, check the button and not write the code for reading the temperature of the CPU and figuring out when is a good time to switch off and how long should I delay, etc., etc. It will require us to write possible or breakable programs though that can allow for that type of action. But I think that will come more and more when we have more renewables on the grid. We might have to, I think we are going to have to accept that we live in a world where electricity fluctuates, where there are time with more electricity, time with less electricity, and our software is going to have to get on with their lives anyway, and sort of gracefully scale up and down depending on that. And temperature can be the same type of variable, right? Something we did touch a little on in the book is repairs, right? Sometimes you might notice that some part of your server always kicks the bucket first. Typically, it's like your disks, because they get a lot of attention, especially mechanical disks. So maybe you can even change your software to write less and keep those disks around for longer. That's, again, a little harder thing, but it's definitely possible. And it can, depending on the scale you operate on, it can definitely be a worthwhile exercise to at least investigate.
Yeah, food for thought indeed. And by the way, this Echo program on your washing machine, I learned very recently that this is the only program that is tested when they deliver the Echo label. So it means that when you buy a washing machine with A or B ratings, etc., because you're very conscious about electricity consumption savings and water savings as well. If you use any other program, there is no promise at all that there's ratings would be achieved. So they test only on the Echo program. So I guess we have to trust them and use the Echo program a lot.
Oh, that's interesting. I didn't know.
But Sarah, I know that you wanted to talk about this topic as well, because that's one of your area of expertise, something very dear to my heart, actually, measuring. And my first question would be, how accurate our measurement needs to be to start to do things or to be actionable?
Yeah, it's a great question. And I think different people have different points of view here. I am firmly in the camp of don't let perfect be the enemy of progress. I don't think perfect measurement, of course, it's a goal. It will be great if we could have perfect, reliable, trustworthy carbon data. That would be amazing. We don't, however. So we can't halt all progress just because we don't have this perfect measurement yet. Sometimes I feel people get so caught up in it. It's like, oh, but if I don't have these numbers to report, then I can't show that I made progress. And then there's no point of making progress. And that is exactly what I don't want to happen. So I don't think we need to have perfect measurements. I do think you have to be scientific in the way you measure, though. You can't measure one way first, do some changes, and then measure a completely different way. Obviously, then the result isn't scientific. So you need to keep a scientific approach and measure in the same way. But it's fine to use a proxy, like just measuring energy. It's fine to use cost, for example, if you do it a bit smartly. It's fine to use the amount of hardware that you use as a proxy. You don't have to measure every single detail just to do something, is what I really firmly believe.
And what is interesting in what you say is it's not only a question of having impact metrics like carbon equivalent emissions, water consumption, abiotic resource depletion, etc. Having them in a not so accurate way, although always scientifically measured and with a scientific process, because as you say, but you're also fine with using proxy metrics, like, for instance, for trying to assess the carbon footprint of a website. There is this big debate around whether the weight and the amount of data being exchanged over the network really matters or not, and whether it matters short term, etc. Well, big debate. But your point is, that's fine to use also this kind of proxy metrics, as long as we know that they go sort of in the right direction and that we measure it in a scientific way.
Yes, you can always find more things to measure, more complex ways to think about things. There's always more data, more things to consider. What about erosion of the soil? What about eco-diversity? What about water use? What about this and this and that? You can add on, and then you end up in a state of analysis paralysis where you are just trying to model the perfect reality to make decisions. And that can be a fun exercise to do. And I'm very glad that there are lots of people who are doing it, so the rest of us can make use of that eventually. But that shouldn't stop us from start doing progress today, because I am convinced that almost everyone is writing software. They know at least one thing they can do to be more efficient. And they might not be able to say it's like a 10 times more carbon efficient or even 1 time more carbon efficient, but they know it will be better. So just having something that can show some number, maybe so you can just show your manager or your leadership, whoever, decides if that was a good or a bad thing, then I think it's a good thing. I think it's a valid thing, because we are in this state where we can't really afford to sit back and just do the numbers for a while. We need to do action. We need to do things, preferably yesterday.
I'm on you with this one, that actually it leaves too many people also on the side of the road waiting for the perfect metrics. And don't get me wrong, I'm part of the Boa Vista Association. These folks there is just genius when it comes to metrics, measurement, etc. They run one of the most comprehensive database in the world when it comes to impact of hardware. We're very happy to have this kind of people helping us, but for the 99 other percent, waiting for the perfect numbers will be an issue.
Yeah, and that's why I'm also glad that all major cloud providers, they have some kind of metric now. I dare say none of them are perfect, but a few years ago we didn't even have that. So that is one number you can use to get better, because like you said, the majority of software people should not be spending their time modeling and figuring out the perfect metric. They should be spending their time writing software. And it's great that we have other people who can focus and do this really in-depth analysis. We absolutely need those, but not everyone in the field needs to be doing that.
We've talked since the beginning of the interview of software engineers, but we know that it comes in very different shape and flavors. And the same goes for the sustainability experts in our field. Some of them are very much into cloud. I will slightly disagree that it's better than nothing, but a bit more will be better than nothing when it comes to the data provided by main hyperscalers. But I know also that there are great people within these companies trying to move the needle way higher, I would say. So kudos to them. But I think we could do better regarding especially the revenues at the end of the year. I think they could allocate a bit more money to speed up things, as you say, preferably yesterday.
Agree, yes. And I think also people who are the customers of cloud providers should ask for this because that's how any business operates. What the customer wants is what the business will spend time on. So if people ask for it, it will be a worthwhile investment for the major cloud providers. So that's something that everyone actually can do to make measurements better.
Let's use our consumer power also, whether it's in our personal life or professional life. I have one last question, Sarah, for you. You wrote, the three of you, a full chapter on carbon-aware computing. And I don't know if you had the time to listen or to read the episodes that we've made recently with Ismael Velasco and Hannah Smith on carbon-aware computing and the limits of this approach. Just for the listeners who didn't have the chance to listen to it, the main takeaway from these two great experts is that be cautious about carbon-aware computing because it cannot be used as a silver bullet. Sometimes the idea of shifting over time, over space, your computing workload to go where the grid is greener, aka low carbon. Please stop using the word greener, except me in the subtitle of my show, but it's because I do very lazy marketing tricks. So sorry for this, but otherwise, let's talk about low carbon and renewable. Their main concern, and that connects nicely to what you said about specialization, is that a software engineer and even a data scientist, etc., they're not expert in electricity grid management. And there are some things that we need to pay attention to. For instance, if you shift your workload in a place or in a time where the electricity seems to be low carbon, but actually you're at the very peak of your low carbon production, you might actually trigger the production of very highly carbonized electricity via gas or mostly gas or even coal powered factory. That was one of the issues. The other issue being that for the moment it's a zero sum game, and if you take the low carbon electricity of someone, he or she will have to use highly carbonized electricity, and it cannot be the excuse not to reduce. You mentioned like you reduce, reuse, etc. It cannot be an excuse not to reduce. And there were other aspects, so I cannot redo the entire episode, but I think there were two of the main takeaways of this discussion, which is a nutshell ended up with, we might talk about grid-aware computing rather than carbon-aware computing. And knowing that you're an expert on this topic and you're a very loud advocate on this approach in the Green Software Foundation, what's your take on it? What's your position on this fine-tuning of our approach?
Absolutely. Hannah and Ishmael are giants in this field. They are great people. So obviously they have very smart ideas. So yes, it's once again, the grid is so complex these days. And not everyone has the time or should spend the time figuring this out. And in the book, we do have a chapter on carbon-aware computing, but it's only one chapter out of a whole book because, as you said, it is not the silver bullet. If it was, then we would only write that chapter and be done with the book. But it's not. It's a great tool that can be used. I want to say it's not always perfect considering the signals that we have now, but I believe the signals could be, if they were a little bit better. For example, now we sort of have two signals. We have the carbon intensity of the grid and we also have the cost of the electricity, because typically if it's cheap, no one is competing for that electricity. If it's expensive, a lot of people are competing about that electricity. You could like combine those two signals and get something that's closer to what I think they suggested. But again, I, as a software engineer, don't want to do that. I want someone to do it for me. So I just have a signal that I can read as an API, for example. I think if I'm allowed to be a visionary a little, I think that will come because I think it will be worthwhile. And then all the things that we talked about in the carbon aware space will apply. We'll just listen to a slightly different signal, is what I personally think. I don't think carbon aware computing is necessarily bad. I don't think it's bad at all. Actually, I think it's good. I think it sometimes can be a little counterintuitive. But yeah, that full episode was great, and let's not redo it. But I strongly agree that it's not the silver bullet. It should not be used as a silver bullet, but it is a useful tool to have in your tool belt with all the other things.
Yeah, fair point. So I think we unpacked quite a lot of your book. We need to save some chapters for Sara as well.
Yes.
So maybe I'd like to close the podcast with not this time one, but two questions. The first one is, of course, we talked a lot about your book. You mentioned several references. Do you want to add one or two other references that could be extremely useful? It could be a video, it could be books, it could be articles, podcasts, you name it, to software engineers truly willing to decarbonize the most urgent environmental issue, but of course there are others as well, so to decarbonize their code base.
I think if you're like brand new to the space, the Green Software Engineering course is a really good place to start, to just get your feet wet. It's not super long, and it covers a lot of the like basic stuff. So I think that's really good. Also, the Green Software Foundation podcast, I think it's cozy and nice, and it's similar to this one in the conversational style, and feels, I don't know, I don't like when the rhetorics become very like lecturing. To me, that makes me sort of shy away, because when you're trying to do something good, when you're trying to learn something, you don't want to be like told sternly that you're doing things wrong. And that's also the tone we strive for in the book. Everyone is on their own unique individual learning curve, and no matter where you are, you shouldn't be shamed for not being further along or things like that. It's very important to meet people where they are. And I think this podcast and I think the Green Software Foundation podcast are both. Oh, also, sorry, one more. InfoQ has some good articles recently as well on sustainability and so on.
Thanks a lot for sharing these references. Yes, some of them are, guess, pretty familiar with the listeners, like Environmental Viable, my dear fellow podcast. Hello, Chris and Asim, who are long-standing podcast hosts of this great show. To close the podcast, Sara, could you share a good news, like a piece of good news when it comes to sustainability, or even maybe IT sustainability?
Yeah, well, I had one piece of news that was not really related to IT sustainability, but to sustainability in Norway, where I live. We're actually pretty recently Greenpeace and the Natur og Ungdom, which is it means nature and youth in Norwegian. They won a case against the Norwegian state regarding new oil fields. So the state wanted to do 3 new oil fields, and Greenpeace and Natur og Ungdom, they took them to court, and they won. So there won't be these 3 new oil fields anymore, which I think is pretty great. It's of course very controversial here in Norway, who makes a lot of money from oil. But I think if we really want a low carbon future, then we need to focus on other methods of generating energy. So that was my one piece.
Yeah, that was a great victory, actually. And I guess you won another one very recently with the ban on deep sea mining. That was also very controversial. So it's a good signal, because Norway, I guess, is unfortunately the remaining countries where climate denial has some momentum. I think maybe in Poland as well, but I don't want to say stupid things. Sorry, Lukasz, if you listen to me and I'm saying so. But I think there is or maybe it's Hungary. I don't know. Sorry about that. If I recall well, there is one Eastern country which is still pretty deep in climate denial, and Norway, for obvious reasons like connection with the old production, and you don't really want to kill the hand that nourish you. But that's a very positive news that even in area where the fight against climate change is not as consensual as it should be. I'm not saying that there is no issues in other countries. I mean, in France, to talk about a place I know pretty well, we are between 30 and 35, sometimes 40% of people around some sort of climate denial. So either it doesn't exist, which is a small minority, or it exists, but it's not human related. So I'm not lecturing anyone or any country here, and that was not my point, but it's just that Norway is a specific challenge, as a specific challenge on its own. And still, my main message, that being said, because I didn't want to sound too pretentious or whatever, that was a million of miles away of what I intended to say, that, yeah, we can still, win cases and manage to get massive sustainability achievements. So I think that's a very, very positive news coming from Norway. And thanks a lot for sharing it, Sara. And thanks for joining the show. That was great to have you. I hope we didn't spoil too much the readers. But it was great. I mean, thanks again for making this book happen. I think it's a very important milestone in our road toward more IT sustainability. So thanks a lot for sharing all of this in the show too.
Thank you so much for having me on the podcast. It's been really fun, and taking time out of your busy schedule and early morning and all of those things. So thank you so much for that.
Thank you for listening to this Green.io episode. If you enjoyed it, please share it and give us 5 stars on Apple or Spotify. We are an independent media relying solely on you to get more listeners. Plus, it will give our little team, Jill, Mabel, Tanny, and I, a nice booster. In our next episode, we will talk about politics, or actually how the European Union Parliament has delivered several legislations to green the IT industry, either directly or indirectly. And what does it mean for product and tech people in Europe and beyond, such as GDPR did? I will be joined by the member of European Parliament, Kim van Sparentak, and Max Schulz, the founder of the Sustainable Digital Infrastructure Alliance. Stay tuned. Green.io is a podcast and much more. So visit greenio.tech to subscribe to our free monthly newsletter every last Friday of the month. Read the latest articles on our blog and check the conferences we organize across the globe. The next one is in London on September 19th. And you can get a free ticket using the voucher Green.io VIP. The call for speakers has also been opened, so feel free to apply if you wish to speak. I'm looking forward to meeting you there to help you, fellow responsible technologists, build a greener digital world.
One bite at a time.